Welcome to this brief introduction to Flurry's technology and vision. You may consider this a digest of the deeper learning modules and documentation consolidated from Flurry University. You've learned many aspects about core blockchain concepts, protocols, and standards throughout these modules. Flurry has been built to complement the core transactional blockchains by bringing comprehensive data management to the entire lifecycle of Web3 applications. Flurry combines the benefits of distributed ledger technology with semantic graph database standards, empowering developers and enterprises to deliver next generation applications today, built upon a data-centric architecture. Flurry is most often compared against enterprise blockchain protocols or traditional databases. Flurry can be used as the backing data store for most modern applications tailored to specific requirements of vertical industries. Here are a few very brief examples of use cases from our current portfolio of customers and partners to give you some ideas. The United States Air Force is securing and sharing metadata with a full chain of custody and multi-domain command and control operations. Our partner MarsX Technologies implemented a digital voting solution not only for lessening the attack surfaces within their application, but also meeting the compliance and regulatory auditing standards that were in place. A startup based in the Middle East, Pravica, implemented a Web3 style decentralized private messaging and communications platform. Once again, building this security logic directly into the database for this self-defense of the data being used within their platform. And one other very high growth area is around verifiable credentials, or implementing the W3C standards for the verifiable credentials stack. In this case, the United States Department of Education, working with students, teachers, and employers as the users rolling out this system. But what all these customers and these use cases, what they share in common is the value they place on data. Data has become the core driver of the global economy. And while digital native companies like Google, Netflix, and Facebook are built from their core to leverage data, most of the enterprises and government organizations around the world are just beginning their journey. The benefits are immense, and a growing number of practitioners are putting the principles described at the Data-Centric Manifesto into use. These principles are that data is a key asset of any organization. Data self-describes and does not rely on an application-centric architecture to interpret and give meaning to the data. And it's expressed in open, non-proprietary formats. Flurry's basis of storage and operations is in resource description framework called RDF. It's commonly known as a triple store. Now, RDF is the standard means of representing data on the web today. It is compatible with JSON and other linked data standards and tools already familiar to developers. Number 4 principle relates to the access and security of the data being the responsibility of the data layer. This is crucial in an aspect that Flurry calls data defending itself, where the permission logic is encapsulated and travels with the data elements recorded within the Flurry ledger backplane. Older application-centric paradigms require mind-boggling complexity within application services to manage the security of data within fine-grained microservices and APIs. And this sprawl is bad, and we're getting out of it. And then finally, the applications can visit the data, they can operate on the data, but they're processing it back into the data layer. This is another tenet of data-centric architectures, that applications should be considered ephemeral. The data is the strategic asset. In Flurry, the concept of logic being code as data This allows your blockchain applications to fit and scale in a data-centric architecture. With its more foundational role in our business, new questions about data are emerging as agile methodologies in development and security operations, commonly known as DevSecOps, combines with data operations or data ops. And this whole life cycle looks like this loop here, bringing up some key questions related to blockchain decentralized apps around who owns the data? How is privacy being controlled? How do we know that the data has integrity and it hasn't been tampered with? And who created it? With AI and machine learning continuously making more and more decisions automatically, how do we know how they arrived at those decisions? And most importantly, how do we get more value from our data? And with this more valuable asset in hand, how do we share it with partners, customers, and internally amongst departments, both securely and easily? Traditional databases were never designed to address these new data challenges, and workarounds to try to achieve these challenges, they're not only expensive, but often unintentionally open up security vulnerabilities. Flurry is designed to address these questions at its core with its modular standards-based platform. We help organizations become more digital native, and we look forward to exploring these concepts further with you. So let's dive into the architecture of our product. Flurry Enterprise Edition, our data platform combines the security and integrity of blockchain with the data management capabilities of an enterprise semantic graph database. Now, most legacy databases run the transaction engine handling updates with the query engine handling the reads. This is all on a monolithic architecture they've created for the last 40 years. In order to provide the scalability of a modern database with immutable benefits of a blockchain, Flurry, essentially we've implemented the CQRS design pattern, and CQRS stands for the Command Query Responsibility Segregation. This is a way that you can separate the database into two parts. In this case, Flurry DL is the persistent storage, and Flurry DB is a stateless query interface. Flurry DL is the transaction engine for the system, providing ACID guarantees one would expect from an enterprise operational data store. It essentially acts as a fully immutable historic audit trail that represents every chronological state change to your data. Flurry DL is similar to a change data capture, a CDC log. It very efficiently captures deltas in what can be thought of as traditional CRUD operations, create, read, update, delete. And this can instantaneously reproduce any state down to the millisecond of the database at any point since the Genesis block. Flurry DL can be privately deployed for internal use or distributed across a decentralized network with the option of leveraging consensus algorithms for decentralization. Most common deployment is a permissioned blockchain network running Raft consensus, making it really fast for updates to the ledger compared to other blockchains. Transactions submitted to Flurry DL are signed by the submitter's unique key, and once they pass the rules enforced by Flurry smart functions, they join the blockchain as the next immutable log entry using SHA-3 256-bit hashing algorithms to secure the data and guarantee the integrity of the ledger. Flurry combines transactions into immutable time-stamped blocks and locks each block via asymmetric cryptography for complete integrity. And this immutable ledger of data allows us to categorically prove time and source for every datum in the system. And we had mentioned RDF, and this is a representation framework that stores semantic web data in triples, subject, predicate, object. Flurry extends RDF to include information about time. So there's a temporal dimension to allow for asserting or retracting facts and to support extensible metadata. So these triples then become flakes in Flurry. That's kind of how Flurry got its name, which are flakes are assertions about a fact at any given point in time. And RDF is incredibly flexible and therefore can become the basis of an RDF graph, which is a set of interconnected triples. As a universal way of representing information, RDF can provide an excellent model for expressing ontologies, taxonomies, along with other data science and knowledge engineering principles. Therefore, Flurry is easily interoperable with other standards-based systems. Loosely coupled with Flurry DL is Flurry DB, and this is the semantic graph database that's optimized to make the best use of the flakes, the RDF flake output from the Flurry ledger. Graph databases allow developers to write sophisticated queries that can traverse relationships. Because every update to Flurry DL is immutably recorded, Flurry DB can query against any historical point in time and retrieve an instantaneous response as of that block. We call this feature time travel. Flurry DB is multi-model, which allows you as a developer the choice of standard tools and technologies you already know, when that makes you efficient and effective right from the start. And this includes Sparkle, which allows developers to write queries that join Flurry data, even with data from other RDF sources, enabling a secure semantic web of data and information. GraphQL is an API that's typically used by bots or UI elements. SQL provides us compatibilities with relational database table concepts, and Flurry QL is our native pure JSON-based interface. And then Flurry smart functions trigger automatically on both the update path and the read path, making it possible to embed security and permission logic within the system as data itself. Because these policies are embedded within the data layer, they can leverage any conceivable set of conditions or linked data within the Flurry system as context for evaluation. Smart functions simplify the enforcement of what can be arbitrarily complex data security policies, as well as data shape validation constraints. This is all at the data layer, so it supports data-centric architecture security initiatives such as cell-level security, attribute-based access control models, and granular permissioning logic that relies on linked data relationships. Within this framework, we can open up our data sets to be queried directly by virtually anyone. Data will be filtered out according to the established rules associated with that user's identity. Smart functions can reliably evaluate user identity and user data because of Flurry's fundamental implementation of cryptographic signatures for all queries and transactions. Flurry's technology runs on a simple and lightweight JRE, a Java runtime environment. For deployment across on-premises and cloud, you can run Flurry standalone just on your laptop for unit development. You can scale it out in an AWS cluster, in a Docker container, anywhere else that supports the Java runtime environment. Flurry's even built our entire database system in JavaScript. So you get an in-memory embeddable query engine. This gets data directly next to front-end code, no traversing the wire and paying the latency hit. So a lot of different topology configurations for deploying Flurry. And to put it all together, you can start working with Flurry on demand right away. Flurry hosts and manages this for you, and you can provision a tenant directly from our self-service portal on our website. This picture here represents how Flurry runs our own managed cloud service. You can replicate this or customize it with packages and management on anything from bare metal cloud servers through Kubernetes clusters. As you work towards your own custom Flurry deployment, there are some options here for Flurry Anywhere. You can scale into it. You can start with that all-in-one standalone version that includes everything in one package with a web admin console allowing you to directly write your transactions, queries, create users, monitor your server, etc. As you start to grow with your system, you might want to add more query servers in order to scale your ability to handle an increase in demand generated by your users. The query servers scale independently of the ledger servers to match your right architecture for the right job. You might even create a React or a Node.js application that communicates directly with the ledger. This new layer allows you to control how your users and admins view the data, create new data, and manage the system. As you grow, you may need to scale your ledger servers in the Raft consensus cluster, handling fault tolerance, giving you flexibility in business continuity strategies, or you can start to create multiple ledgers that have their transaction handled within separate logical and physical groupings. So you can bring your own cloud infrastructure with Flurry, and we can be deployed and managed on all the popular cloud infrastructure providers like Amazon, Google, Azure, etc. And you can utilize your own DevOps tool chain and blockchain development tool sets from popular open source providers. There are also some partners Flurry has which greatly automate and simplify the lifecycle for running and managing your project, such as managing Flurry topology and protocol deployments using Zeev.io, for example. Wrapping it up, really, getting started with a tightly scoped project can help you build a solid mental model for how everything works before embarking on your growth plans. Flurry is open source and no charge to provision Flurry on demand or just download and deploy to evaluate it. Go to our website at flur.ee/try. Flurry can scale with you as your business grows. We have a commercial model for enterprise support and extended functionality. And there's a wealth of learning modules behind each of the slides in this short introduction, so you can create a path tailored to your needs. Thank you for investing your time for this introduction to Flurry. We're really enthusiastic to take the next steps with you as part of our community.